Hey everyone, it's Kevin with CGBoost.com, and in this video, we're going to create this stylized microscope in Blender 3D, which was inspired by the past Science Lab challenge. The way we'll do this is by first modeling the microscope, then we'll shade it with a textured material, and lastly, we'll add grease pencil details to give it an illustrated look. If you don't know what grease pencil is, it's an element within Blender that allows you to draw 2D in a 3D environment, and here specifically, we'll be using it to draw on the surface of meshes. If you want to learn more about it, you can check out my grease pencil course I just released with CG Boost. I'll have more info at the end of the video. You don't need to know how to draw, and this tutorial can be followed along by those still fairly new to Blender, although it might be easier if you have some experience with it. Also, a tablet is not required, but it might be helpful towards the end for adding details. And for reference, I'll have the shortcut keys displayed at the bottom right. You can download the final project file and resources used in this video by going to cgboost.com/resources. You can find a link below. Alright, let's get started. So here I'm in a new Blender file using version 3.4 and in the layout workspace. To start, we'll adjust a few scene settings. Let's go to the Render Properties tab here, and just to clarify, we'll be using Eevee to render out this project. Scroll down to Color Management and change the View Transform dropdown from Filmic to Standard. This will make the colors display accurately according to the style we're going for. Also, I like to change the look to medium-high contrast. This is a personal preference, but it'll make the colors appear more vibrant. As we'll be focused on modeling for this first part, I'll keep the viewport shading set to solid. And to help, I'll click on the shading dropdown to the right of it and toggle cavity. This will enable a slight visual bevel to the edges of our meshes to see them more clearly. Going to the 3D viewport, let's delete this cube with X and go into front view with numpad 1. Now, if you don't have a numpad, you can access the different orthographic views through the access controls here, or by going to Edit, Preferences, Input, and toggling Emulate Numpad. This will make the numbers at the top of your keyboard act like the numpad shortcuts. Just keep in mind that this will affect your selection controls while in edit mode. Now, when modeling anything, and something a bit more detailed like a microscope, it's really helpful to have reference. So here I have a side profile that we can use as a guide, and this will be available in the link below. To bring this into Blender, you can simply drag the file into the 3D viewport, and it'll import as an empty. I want to clear any transformations on it, so with it selected, hit Alt-G to clear its position. Then let's go to the Object Data Properties tab and increase the size a bit here to about 6 meters, and then toggle opacity and lower it to about 0.05 so it's transparent. Then I'll go to the Object Properties tab, which is this orange icon, go to Viewport Display and check In Front to make sure this reference will appear on top of any meshes we create. Then let's shift this reference up with G then Z to where the base of the microscope sits on top of the X-axis line. So it seems like there's a lot here, but we're going to tackle this one segment at a time, and we'll start with the arm on the left here. Let's bring in a circle by hitting Shift A, Mesh, and selecting it from the list. With it selected, let's rotate it upward by hitting R, X, and typing 90. Then hit G to grab, and position it to where the left side of the circle fits the outer curve of the arm. I'll size it out slightly with S, and S then Z. Tab into Edit mode, and with Point Select, you can either hit 1 or by clicking these buttons at the top, box select all the vertices that don't sit on that left curve and delete them with X. I'll also select this top point individually and shift it with G to fit this top segment. And then I'll do the same for the bottom. Once you're done, go back into object mode. Let's duplicate this curve with Shift D and then X to shift it over to the right so this curve fits the inner part of the arm. I'll also size it down with S then Z just a bit. Tab into edit mode and like before, delete the points that aren't positioned on the curve except for the ones at the top and bottom. Then shift the points slightly to roughly fit the shape of the reference. It doesn't need to be exact as we'll be doing some beveling later to smooth it out. Go back into object mode, shift select both curves, and hit Ctrl J to join them into one object. Then tab back into edit mode. Select the top point of the inner curve and hit E then X to extrude and shift it over until it hits the right edge of the arm. Then extrude again with E then Z upward until it's level with the top point of the other curve. Shift select both the top points and hit F to connect them. Select the bottom point of the inner curve, and like before, hit E then X to shift it over until it hits the right edge of the arm base. Then hit E again to extrude it down diagonally to where it's above the outer curve's bottom point. Shift select both of those points and hit F to connect them. Make any adjustments needed. Then hit A to select all, and then F to fill this shape. We're going to extrude this, so go into side view with numpad 3. With the shape still selected, hit E to extrude to the right along the Y, and make this a little less than 2 grid squares wide in total. And just for reference, I'm using default units. Click to confirm. Tap into Object Mode, and right-click to set Origin to Geometry. Now, I want to shift this back in the Y so it aligns with the world origin. Go to Object at the top, Transform, and select Align Objects. Expand the menu at the bottom left, select Relative to Scene Origin, and align along the Y. Then it'll be positioned accordingly. With it positioned, I want to start beveling some of the edges here, and we'll start with the ones on the inner side. In Edit mode, hit 2 for Edge Select, and again, you can also access this from the buttons up here. And Shift select the inner edges except for this bottom one that holds the stage here. Hit Ctrl B to bevel them, and increase the number of cuts with your middle mouse wheel until you get a smooth curve. Click to confirm. If you don't have a middle mouse wheel, you can adjust the number of segments by expanding the bevel menu at the bottom left that appears upon confirming. Then select the edges on the outer side of the curve, except for the bottom one, and bevel those as well. Lastly, select the inner edge on the right side, near the base, and bevel that. Check it in front view. Now, I want to create the last segment that connects the arm to the tube, so hit 3 for Face Select, and select this inner face of the arm. Hit I to inset, and roughly size down the new face according to the reference. Go into Front View, and hit E to extrude until it hits the tube. Click to confirm. When you're finished, tab back into Object Mode, right-click, and select Shade Auto Smooth. Rotate your view to check it, and make any other adjustments needed. Next, we'll model the stage, which is this rectangular plate here. In Front View, hit Shift A and bring in a mesh cube. Let's move it up with G to where the origin point is centered to the stage reference. Then size it down with S until it fits the width. Size it in with SZ until it fits the height. Going to Side View, I'll scale this in slightly with S then Y. Now, we'll need to make a hole in this stage for light to pass through from underneath it. With it still selected, hit Shift S to set cursor to Selected. Then hit Shift A to bring in a mesh cylinder. Hit N to bring up the side menu, and size down the cylinder to where it's about 0.19 meters in the X, Y, and Z. Click to confirm. To create the hole, select the stage, go to the Modifier Properties tab, and add a Boolean modifier. In Object, select the eyedropper tool and sample the cylinder we just created. This will non-destructively create a hole in our stage, and if I hide the cylinder, you'll see this more clearly. However, I want this hole to be a part of the actual geometry, so let's apply the modifier by hovering over it in the panel and hitting Ctrl A. If I tab into Edit mode, you'll see the hole integrated into the geometry. In Object mode, delete the cylinder and select the stage. Now, the next thing we'll do is apply Scale Transforms, which is resetting an object's scale value. This doesn't reset its visual scale in the viewport, and it's important for other Blender functions to work properly with this object. You can do that by hitting Ctrl A and selecting Scale from the list. To see if it's been applied correctly, you can check the scale values in the side menu, and if they're 1 in the X, Y, and Z. Lastly, right-click and select Shade Auto Smooth. Now, we'll create the clips that sit on top of the stage, and we'll start with the fastener. So in Front View, hit Shift A and bring in another mesh cylinder. Move it to the left over the reference and size it down until it fits the radius of the bottom portion. Tab into Edit mode, and with Face Select, select the top face of the mesh. Go into Front View and hit E then S to extrude and scale it outward. Then hit E again to extrude upward to form the head of the fastener, and until it matches the height of the reference. Now, to create the actual clip, go into Object mode and hit Shift S to set cursor to Selected. Then hit Shift A to bring in a mesh plane. Shift it up in the Z a bit and size it down with S until it's about the radius of the fastener head. Tab into Edit mode, and with Edge Select, select the right edge. Go into Front View and hit E to extrude it downward diagonally per the reference. click, extrude again along the X to fit the length, click, then extrude upward diagonally, and click. Lastly, select the left edge, go into front view, and extrude it diagonally upward to the left and finish it off. Make any positioning or sizing adjustments needed. Now, shift select the 4 inner edges and bevel them with Ctrl B to smooth them out. Again, adjusting the number of segments with the middle mouse wheel. Then shift select the edges at each end and hit Shift Ctrl B to bevel the corner vertices and round out the ends. Tab into Object Mode and let's add a Solidify modifier to give it some thickness. Set the thickness value to about 0.12 meters. Then hover over the modifier and hit Ctrl A to apply it. Shift select the clip and fastener meshes and hit Ctrl J to join them into one object. Then apply scale with Ctrl A and right click Shade Auto Smooth. Move this closer in the Y near the left side of the stage and we'll mirror this for the other side. Go to the Modifier Properties tab and add a mirror modifier. Under Axis, toggle off X and toggle Y. Then for Mirror Object, I drop the stage to mirror according to its origin point. Then let's apply this modifier by hovering over it and hitting Ctrl A. And now our stage is complete. Next, we'll move on to the base supports, which will be situated on each side of the arm. In front view, hit Shift A and bring in a mesh cube. Size it down until it fits the width of the base support. Then go into Edit mode and with Face Select, select the top face. Go back into front view and let's shift this up with G then Z until it hits the bottom of the stage plate. With Edge Select, select the top left edge, and in front view, shift it along with G then X until it matches the left side slant. Now, tab back into Object Mode and hit Ctrl A to apply scale. Tab into Edit mode and with that edge still selected, bevel it with Ctrl B until it matches the reference. Go into Side View, hit A to select all, and size the support down in the Y until its width is a bit thinner than the arm. Tab into Object Mode and shift it over to the left with G then Y. Right-click Shade Auto Smooth. Then mirror it for the other side by adding a mirror modifier. In Axis, specify Z, and for Mirror Object, the arm. Then apply the modifier by hovering over it and hitting Ctrl A. Now we'll create the hexagonal bolt that connects the supports to the arm. In front view, hit Shift A to bring in a mesh cylinder. Expand the menu in the bottom left and under vertices, specify 6. Then size down the cylinder and shift it over the bolt reference. Scale it to where it's approximately the radius of the bolt. Rotate it with R, X, and typing 90, then position and adjust it as needed. Go into Side View and scale the bolt lengthwise in the Y until it comes outside the base supports. Then hit Ctrl A to apply scale, and now we have our finished base supports. The next segment we'll create is the base that our microscope will sit on. Let's hit Shift C to set the 3D cursor back to the world origin and go into front view. Hit Shift A and let's bring in a mesh cube. Place it over the base reference and size it down until it's roughly the length of it. Then size it down with S then Z until it fits the height. Go into Side View and scale it in with S then Y just a bit. Hit Ctrl A to apply scale and go back into front view. Now we'll start shaping this. Tab into Edit mode and hit Ctrl R to create one loop cut lengthwise. Click to confirm. With Edge Select, select the top right edge, go into front view, and push it to the left along the X according to the reference. Now, while holding Alt, Shift select the 2 corner edges on the left and bevel them with Ctrl B to round them out. Then switch to Face Select with 3, select the top face, and hit Ctrl B to bevel that as well. Tab back into Object Mode, right-click, Shade Auto Smooth, and now our base is complete. Now we'll move on to our light source. Go into Front View, and in the reference, it's the parts underneath the plate. This is supposed to be something circular, so hit Shift A, and let's bring in a mesh cylinder. Make sure vertices is 32, size it down, and position it over the reference. Let's size this down with S to roughly fit the radius. Then size it down in the Z. Now I want to inset these faces, so in Edit mode and with Face Select, Shift select the top and bottom faces of the cylinder. Hit I to inset just a bit, click, then hit E, S, and Z to extrude the new faces inward. When you're finished, tab into Object Mode, apply Scale with Ctrl A, and right-click Shade Auto Smooth. I want to create the support for this light source. Tab back into Edit mode, and with Face Select, hold Alt to loop select the outer faces of the cylinder. Hit Shift D to duplicate the faces, right-click to leave them where they're at, and hit P to separate by selection. It brings the duplicate faces into a new object, so tab into Object mode, select the new mesh, and go back into Edit mode. Toggle X-ray with Alt-Z, or by clicking the button up here, and go into Front View. Select half of the faces on the right side of the ring, and delete them with X. Toggle off X-ray. Then with Edge Select, Shift select the outer edges of the ring, and hit Shift-Control-B to round them out. Tab into Object mode, and scale this out with S just a bit. Now let's add some thickness to this. Go to the Modifier Properties tab, and add a Solidify modifier. I'll set the thickness to about 0.02 meters. Then I'll hover over it and hit Ctrl-A to apply it. Tab into Edit mode and toggle X-ray again. With Face Select, Shift select the two faces in front of the arm. Hit E then X to extrude it towards the arm. Toggle off X-ray, tab back into Object mode, apply Scale with Ctrl-A, and right-click Shade Auto Smooth. Select the circular light source mesh, go into Front View, and let's rotate it upward to match the reference. And now the light source is complete. Make any adjustments needed. Now we'll move on to the top half of the microscope, starting with the tube and eyepiece. In Front View, let's bring in a mesh cylinder with Shift-A. Size it down and place it over the tube portion of the reference, which is the bottom half. Size it down until it roughly matches the radius of the tube. Then size it vertically with S then Z. Tab into Edit mode, and with Face Select, select the top face of the cylinder. Go into Front View, and using the reference, extrude it with E then S outward. Click. E upward. Click. E again upward. Click. Then S to scale it in. Click. E upward. Click. E then S to scale it in slightly. Click. Then E upward to create the eyepiece. Click. E S outward slightly. E upward. Then E S outward again slightly. Then E upward again, but I'll stop a little below the top since it curves in. Then hit E again to the top, and S to scale it in slightly. Then to create the hole, I'll inset with eye just a bit, then E to extrude downward into the tube. Now I want to round out some of these edges, so tab into Object mode, and let's apply Scale with Ctrl-A, and right-click Shade Auto Smooth. Tab back into Edit mode, and go into Front View. I'm going to create one loop cut around this slanted portion with Ctrl-R. Click to confirm, and scale it in slightly with S. I'll shift the cut down the slanted portion slightly by hitting G twice. Then hit Ctrl-B to bevel it and increase the number of cuts as needed. While holding Alt, loop select that ring right under that top portion and hit Ctrl-B to bevel that as well. And now our tube and eyepiece is complete. The next part we'll move on to are the focus dials, which are the circular shapes on the left. In Front View, hit Shift-A and bring in a mesh cylinder. Bring it up and size it down to where it's roughly the radius of the larger dial. Then rotate it with RX90 and adjust it as needed. Go into Side View with Numpad 3 and shift this over to the left with G then Y. Scale this in with S then Y until it's about 1 grid square wide. Now I want to create a smaller extruded segment on the right that connects to the arm. Tab into Edit mode, and with Face Select, select the face on the right. Hit I to inset until it's a little less than half the radius, and click. Toggle X-ray, then extrude with E to the right until it hits the arm. Tab into Object mode, and go into Side View. Shift the dial over to the right along the Y to close the distance. Then toggle off X-ray. Now tab into Edit mode and select the face on the left side of the dial. Go into Front View and inset the face until it matches the outer middle ring. Click. Go into Side View and hit E to extrude this to the left slightly. Click. Go back into Front View and inset again with I until it matches the smaller circle in the middle. Click. Then go into Side View and extrude it slightly one more time, and click. Tab back into Object mode and hit Ctrl-A to apply Scale, and right-click Shade Auto Smooth. Now we'll do some beveling. Tab into Edit mode, and with Edge Select while holding Alt, Shift select the outer edges of the dial, except the one on the far left. Bevel it with Ctrl B. However, unlike the other beveling we've done, I won't increase the segments for this as I want a slanted edge. Then with face select the far left face and bevel it as well. This time, increase the number of segments to round it out. Tab into object mode, and that completes our larger dial. For the smaller one, go into front view and bring in another mesh cylinder with Shift A. Size it down and bring it up over the smaller dial reference. Size it down until it fits the radius of it. Then rotate it with RX and typing 90. Go into side view and toggle X-ray. Scale it in the Y a bit and shift it over to the left along the Y until it comes out from the face of the arm. Go into edit mode and with face select the left face of the cylinder. Go into side view and hit E to extrude it slightly to the left. Click. Toggle off X-ray. Then go into front view and hit S to scale it in until it matches the middle ring. Click. Go into side view, hit E to extrude it outward to the left again. Click. Then hit I to inset. Click. Then E to extrude inward. Click. Tab back into object mode and make any adjustments needed. Then apply scale with Ctrl A and right-click Shade Auto Smooth. And now our focus dials are complete. Alright, almost done with the modeling. The last thing we'll need to create is the rotating turret and 3 lenses that attach to it. We'll start with the lenses. Go into front view and bring in another mesh cylinder. Size this down and move it over the reference. Scale it in until it matches the radius of the lens barrel. Then tab into edit mode and with face select the bottom face. Go into front view and hit E to extrude this downward a bit. Click and scale it in with S. Click. Hit E then S to scale it in slightly. Click. Then E to extrude it downward. Click. E then S to scale it in again. Click. E to extrude it downward. Click. E then S to scale it in one more time. Click. Then E to extrude it downward and finish it off. And click. Tab into object mode. Apply scale with Ctrl A and right-click Shade Auto Smooth. And now our lenses are done. We're going to duplicate this 2 more times for the other 2 later. Now to create the turret, bring in another cylinder with Shift A. Shift it over the turret reference and size it down until it roughly matches the radius of the top portion. I know it's a bit weird because it's slanted, but it doesn't need to be exact. Size this down with S then Z to match the height of that top portion. Then tab into edit mode and with face select the bottom face. Go into front view and hit E then S to scale it out slightly. Click. Then E to extrude downward until it's a little taller than the top portion. Click. And S to scale it out slightly. Click. With the bottom face still selected, hit X to delete only faces. Then with edge select and while holding Alt, loop select that bottom ring. Hit Ctrl F to bring up the face context menu and select Grid Fill. We're going to create that curved bottom portion, so hit 1 for point select and select a point in the middle of the new grid. Go into front view, toggle proportional editing at the top here, which is this radar looking icon, and click the drop down. Toggle connected only and change the fall off to sphere. Shift the point down in the Z while adjusting the fall off with your middle mouse wheel to create that curved portion. When you're finished, toggle off proportional editing with O and tab back into object mode. Apply scale with Ctrl A and right-click Shade Auto Smooth. Now we'll attach the lenses to the turret. Select the turret and lens and isolate them with slash. Select the turret individually and hit Shift S to set cursor to selected. Change the transform pivot point to 3D cursor by accessing it up here or by hitting period and selecting it from the pie menu. Select the lens and rotate it with R, Y, and typing 20. Now, if the top of the lens doesn't fit completely in that curved portion, you can just shift it to your liking with G then Z. With the lens still selected, go into top view with numpad 7 and toggle X-ray. Duplicate it with Shift D, then R, typing 120 to rotate it 120 degrees. Then hit Shift R to repeat the action. Toggle off X-ray and check to make sure everything looks good. Then select the 3 lenses and shift select the turret last. Hit Ctrl P to parent the lenses to the turret. Then hit slash to unhide the other elements and go into front view. With the element still selected, hit R and type -20 to rotate the turret with lenses. Shift it over to the left to make sure the left edge lines up with the tube and make any other adjustments needed. I want the turret to be wider, so I'll select it, go into edit mode, hit A to select all, and hit S-Shift-Z twice to size it according to its local axis. When you're finished, change the transform pivot point back to medium point, and now we have our microscope modeled. Make sure to save your work. Let's hide the reference in the outliner. Before we move on, I want to make sure the faces are oriented in the correct way. To do that, go to the Overlays dropdown here and toggle Face Orientation. If it's all blue, that means all the faces are correct. If you have any that are red, select that mesh, tab into Edit mode, hit A to select all, and hit Shift-N to recalculate normals. Let's toggle off Face Orientation and select all the meshes. Hit M to send them to a new collection named Microscope. With our microscope modeled, we can now move on to shading. But before we do that, I want to set up a camera, animate it, and specify a background color. To do this, I'll head into the animation workspace by accessing it from the tab up here. With the left viewport set to the camera view, I'll use the right to find a rough angle that I like, kind of diagonal to it. Then I'll hit Alt-Control Numpad 0 to set the camera view to this angle. Moving out of it in the right viewport, I'll adjust the camera object while referencing the camera view on the left. I'll pull this object back with G then Z twice to adjust it by its local value. Then I'll bring this up in the Z and angle it downward with R. Now I want to animate this camera to subtly rotate around the microscope, side to side. So hit Shift-C to set the cursor to the world origin. Let's bring in an empty cube to see this more clearly, and then parent the camera to the empty by shift-selecting the camera, then the empty, and hitting Ctrl-P. Now go to frame 1, and you can do that quickly by hovering over the timeline and hitting Shift-left arrow. Rotate the empty along the Z to a good starting angle, and hit I to keyframe the rotation. Then go to frame 125, rotate it to the right slightly, and hit I to keyframe that rotation. Select the keyframes at frame 1, duplicate them with Shift-D, and place them at frame 250. And now we have a repeating side-to-side motion. Feel free to adjust the camera to your liking and adjust the number of frames. However, for this tutorial, I'll just be keeping it at 250. Go back into the layout workspace, and starting from this point, we'll set our viewport shading to Material Preview. Also, let's click the dropdown and toggle Scene Lights and Scene World. Lastly, go to the World Properties tab, and let's change the background to a lighter color. I'll select a pale light yellow. And now we'll move on to shading. Let's hide the camera object and cube empty by selecting them and hitting H. Then change the dope sheet down here to the shader editor and collapse this side menu with N. For shading, we have two main materials, a light and a dark color. They're pretty much the same except for the colors picked, and depending on which mesh they're applied to, a new material is created based off one of those in order to adjust specific settings. We'll start with the light material. Select the base mesh and hit New. Rename this material to Light, and we'll create a basic toon shader setup. Hit Shift-A to bring in a new node and search Shader to RGB. This node only works with Eevee and will help in achieving a non-photorealistic look. Drop it in between the principal BSDF and the material output node. Hit Shift-A again and bring in a color ramp. Drop it right after the Shader to RGB node. Change it from linear to constant, and then you'll see an obvious color change. Now, if you see these strange artifacts in between the colors, these are shadows from lights as this shader is affected by them. To remove them, let's click on our light object, go to the Object Data Properties tab, and uncheck Shadow. Click back on the base mesh. So here we can change these slider colors to whatever we'd like, but before we do that, we'll work on the texture. Moving to the left of the principal BSDF node, hit Shift-A, and let's bring in a gradient texture node. Then hit Shift-A again and bring in a Voronoi texture node. Lastly, bring in a mix node. Change float to color, and if you're using an earlier version of Blender, this node was previously called Mix RGB. Connect the gradient texture color output to the B input of the mix node, and the Voronoi color output to the A input. Then connect the result output from the mix node to the base color input of the principled BSDF. Then you'll see a pattern where the color transition is. Now, let's adjust a few options. Going to the Mix node, set the factor to 0.7. Then go to the Voronoi texture, change this from 3D to 4D, and set the scale to 175. And now it's closer to the look we're going for. However, it looks a bit stretched in some areas of the mesh, so we're going to bring in a mapping and texture coordinate node. If you have Node Wrangler activated, which is a free add-on, you can select one of the texture nodes and hit Ctrl T. If you don't, hit Shift A and bring in a mapping node. Connect the vector output to the vector input of both texture nodes. Then hit Shift A again and bring in a texture coordinate node. Connect the object output to the vector input, and then the texture should display correctly. When you're finished, box select all the nodes and hit Ctrl G to group them together. This places the selected nodes into a separate group, which is helpful for organization. Now, the last thing I want to do is drag the Voronoi scale input to the group input output, and then I'll collapse this group with Tab. So you'll see that our nodes have been placed within this material in another node, and if you want to access this group again, you can just hit Tab. Now, we place the scale output here to be able to adjust it outside the group setup, and you can change this value if you'd like. For now, I'll be leaving it at 175 for all the materials in this tutorial. Now, we'll move on to adjusting the coverage and changing the colors. Going to our color ramp, let's drag this white slider over to the left a bit. I'll change this black to a medium blue. I also want another color in between the blue and white, so I'll hit this plus icon to add another slider. I'll make this a lighter blue. And feel free to pick any colors you'd like. Then I'll adjust the slider positions until I get something I'm happy with. I want this white to be the highlight color, so I'll shift it a bit more to the right. And this is our general shader setup. Let's copy this over to some of the other elements in our scene. Shift select the base supports, arm, tube, then base mesh last, and hit Ctrl L to link the materials. Before we make mesh specific adjustments, let's adjust the light object we already have in our scene. Again, this will affect the shader, so bring it down closer to the microscope with G then Z, and then G then X. Now, as previously mentioned, I created new materials for some of the meshes based off the one we just created, so I could individually adjust settings for each mesh like the color ramp sliders. So in looking at the arm, I want to adjust the color coverage on it. Let's select it and click on this number to create a new material and make a single user copy. Rename it to light arm. And now we can adjust the color ramp sliders without affecting those linked. If you want to make specific adjustments to this node group on the left, you can make a single user copy as well by clicking the number. But I'll keep it as is for any new materials we'll create. Let's repeat this process for the tube. So select it, create a single user copy by clicking on the number, and rename it to light tube. Then adjust the sliders as needed. Feel free to adjust the lighting position as well. Now, from this node setup, we can create the dark material. Shift select the stage mesh, then the base, and hit Ctrl L to link the materials. Then click on the stage mesh, create a single user copy, and rename it dark. For this, I'll change the medium blue to a royal, almost purple blue, and for this light blue, I'll eyedrop that royal blue and lighten it a bit. I'll leave the white as is and adjust the slider positions. Let's apply this to the other meshes. Shift select the light source meshes, hexagonal bolt, stage clips, focus dials, turret, lenses, and the stage last. Then hit Ctrl L to link the materials. Now let's adjust the coverage individually for each segment, starting with the clips. Select them, create a single user copy, and rename it Dark Stage Clips. I want to bring in some more of the white, so I'll shift this slider accordingly. Then select the circular light source mesh, create a single user copy, rename it Dark Light Source, and again, bring in more of the white. Let's apply this to the light source support by shift selecting it, then the circular mesh, and hitting Ctrl L to link the materials. Next is the hexagonal bolt, and I'll create another single user copy and rename it Dark Hexagon Bolt. Then I'll adjust it like we did previously. For the focus dials, I think they can share the same material as the hexagon bolt, so I'll shift select both of them, the bolt last, and hit Ctrl L to link the materials. Moving on to the turret, I'll create another single user copy for it and rename it Dark Turret. I want the majority of it to be white, so I'll shift the sliders accordingly. Then for the lenses, I'll select one of them and repeat the process. I'll create a single user copy, rename it Dark Lens, and adjust the slider positions as needed. Let's apply this to the other two lenses by shift selecting both of them, the adjusted one last, and hitting Ctrl L to link the materials. Going to the tube, I want to make the eyepiece portion dark. Let's select the tube and go to the Material Properties tab. Hit the plus button and bring in the dark material. Tab into Edit Mode, toggle X-ray, and hit 3 for Face Select. In Front View, select the eyepiece portion of the tube, and with the dark material selected in the Material Properties tab, click Assign. Tab into Object Mode. I want to adjust the coverage slightly, so let's create a single user copy and name it Dark Tube. Then adjust the slider positions. Lastly, going to the larger focus dial, I want to make a portion of it the light material. Select it, go to the Material Properties tab, and hit the plus button to bring in the light arm material. Then tab into Edit Mode. Go into Side View, and with X-ray still toggled, select the left portion of the dial and assign the light arm material to it. Toggle off X-ray and tab back into Object Mode. And now our shading is complete. To help adjust this, I'm going to bring in a few lights to vary the coverage in some areas. I want to place one on the stage, so let's shift right click on top of the mesh to set the 3D cursor on it. Then hit Shift A to bring in a point light. Set the power to 5 and uncheck shadow. Position it near the hole in the stage. Then duplicate this light and position it towards the back left side of the microscope. Feel free to make any other adjustments needed. When you're finished, shift select all 3 lights in the scene and hit M to send them to a new collection named Lights. And that completes our lighting. Let's change the shader editor back to the dope sheet and make sure to save. So we're almost done with our microscope. Now we'll move on to working with Grease Pencil, starting with the outlines. For the outlines, I use the Grease Pencil Line Art modifier. To do that, make sure your microscope collection is selected in the outliner. Then hit Shift A, Grease Pencil, and select Collection Line Art. Immediately, this will generate line art around the geometry of your mesh. It goes by your camera view, so let's go into it with numpad 0. To see the outlines more clearly, toggle off overlays by clicking the button at the top or by hitting Shift-Alt-Z. Now let's adjust the line art. To access these settings, go to the Modifier Properties tab. In line thickness, reduce it to about 10. Then go to the Material Properties tab and rename the material to Outline, and change the stroke base color by eyedropping the royal blue color on the dark material. Now there are a few areas where I wanted the outline to appear, like on the base mesh, and to fix that, we can mark edges manually so they're included in the line art. Toggle overlays back on, and let's select that base mesh. Tab into Edit Mode and hit 2 for Edge Select. While holding Alt, loop select the top edge of the base mesh, and right-click, select Mark Freestyle Edge. Then loop select the edge underneath that bevel, and right-click Mark Freestyle Edge as well. When we tab back into Object Mode, you'll see those edges included in the line art. Scrub the timeline to check the line art has been generated correctly on the meshes. If you have the Grease Pencil Tools add-on installed, you can use Alt middle mouse click to scrub directly in the viewport. And just a quick note, if you want to install that add-on and the Node Wrangler add-on I mentioned previously, you can just go to Edit, Preferences, Add-on, searching them here, and checking the box to toggle them. Back to the line art, if you have any other edges where you want the outline to show up, you can just mark them in this way. Now, if you find your system is slowing down because of this, you can either hide the line art in the outliner, or you can try baking it. To do that, go to the Modifier Properties tab. Under Bake, select Bake Line Art, and it'll take a few moments depending on your system. However, I advise holding off until finishing the rotating turret, which we'll do in an upcoming part. So we have the outlines done, but I want to add more details with Grease Pencil, and it'll just be a few dark and white lines to augment that illustrated look. This is where it might be helpful to have a tablet, although again, it's not required. Situate your playhead at frame 1 and hit Shift A to bring in a new Grease Pencil blank. Rename this to Microscope Details. We'll start with the dark lines. So go to the Object Data Properties tab, and in the Layers panel, rename the layer that's created to Dark Lines, and uncheck Use Lights. Go to the Material Properties tab, and let's switch out that black material for the outline material. Go into Draw mode by hitting Ctrl Tab and selecting it from the Pi menu. Set the radius to 10 pixels, uncheck Use Pressure, and Strength to 1, uncheck Use Pressure. Set the stroke placement to Surface and Offset to 0.02. This placement will allow us to draw with Grease Pencil directly on top of meshes. With the Draw tool selected, which is this pencil icon, go into Front View and we can start drawing. I'll start with the arm, adding details along the edges. And if you'd like a smoother stroke, you can hold down Shift to enable a pulled string mode. Be careful with the lights as they're objects you can accidentally draw on when using surface stroke placement. Check it in camera view intermittently. Now I want to add some strokes on the inner part of the arm, but to do so, I'm actually going to enter orthographic view with numpad 5. When using surface stroke placement and not in a specific plane view, it's a bit tricky to get a consistent offset depending on your distance from the mesh you're drawing on. Going into orthographic view helps in maintaining the offset we've specified. I'll just draw these lines across, then down its length, and a bit more near the bottom. And I'll check it again in camera view. I'll move on to the stage and add some details. Then the base supports, and if it helps, you can hide the light collection in the outliner. And then the actual base. And here I'll add some vertical and horizontal lines on the side of it, then the front of it, and then the top of it. Then the tube, and then the eyepiece. I'll ignore the turret and lenses for now, go into camera view, and adjust any strokes as needed. Go to frame 1 again, and go to the Object Data Properties tab. Let's create a new layer. We'll move on to adding white lines, so let's name it White Lines, and uncheck Use Lights. Go to the Material Properties tab, click the plus button to add a material slot, and click New to create a new material. Rename it to White, and change the stroke color to white. Similar to what we did previously, I'll add the white lines to certain meshes. So I'll start with the dials, then the tube, and then the eyepiece, then on the arm here, the stage and around the hole, then some on the base supports, hexagonal bolt, and then the light source. And lastly, the base. As a finishing touch, I'll right-click to switch back to the dark lines layer, and we'll set the active material to outline. Then I'll add these small marks randomly on the meshes. When you're finished, go back into object mode and into camera view to check it. The last element we'll need to work on is the rotating turret. So we'll first animate it and then add grease pencil details to it afterward. To animate it, we'll use object constraints. Let's get out of orthographic view with numpad 5 and hit Shift A to bring in a plane axis empty. Shift it over to the right in the X, then push it back in the Y. Select the turret mesh and go to the Object Constraint Properties tab. Let's add a copy rotation constraint and set the target object to the empty we just created. For axis, uncheck X and Y, and in Mix, select After Original. When I rotate the empty along the Z, you'll see it affects the local rotation of the turret. With the playhead at frame 1, hit I to keyframe the rotation of the empty. Then go to frame 125 and hit RZ360. Hit I to keyframe the rotation there. Then duplicate the frames at 1 and place them at 250. And now our turret rotates back and forth. Let's add some grease pencil details onto this. Select the microscope details grease pencil object and hit Shift D to duplicate it. Rename it to turret details in the outliner or by hitting F2. Shift select the duplicate grease pencil object in the outliner, then the turret in the viewport, and hit Ctrl P to parent it. Select the turret details object in the outliner, which is now a child of the turret mesh, and tab into edit mode. Hit A to select all, and then X to delete. Hit Ctrl Tab to go into draw mode, and right click to make sure you're on the dark lines layer, and the active material is outline. Go into orthographic view, and let's add line details to the turret. To draw on the other side, you can just advance the timeline and add details as needed. Then right-click to switch the active layer to light lines and active material to white. And now we'll draw lines on the lenses. When you're finished, go back into object mode and check it again in camera view. Make sure to save. And that completes our microscope. As a finishing touch, I had a rough grid underneath it. To do that, select the Microscope Details Grease Pencil object and go to Frame 1. Go to the Object Data Properties tab and create a new layer. Place it at the bottom of the layer stack, rename it Floor, and uncheck Use Lights. Go into Draw mode and hit Shift-C to set the 3D cursor to the world origin. Now, set the stroke placement to 3D cursor and the drawing plane to top. Make sure your material is set to outline and go into top view with numpad 7. Then we can roughly draw these lines horizontally and vertically to form a grid. When you're finished, head back into object mode. Now, the last thing we'll need to do is to go to the View Layer Properties tab and under Data, make sure Z is checked. This is so that Grease Pencil will respect meshes when rendering. To render this out, go to the Output Properties tab, which is this printer icon. Specify an output location, and for file format, it's generally recommended to render a sequence of images, but if you'd like to render out a video, you can select FFmpeg Video for file format. Go down to Encoding, and for container, select MPEG-4. For output quality, select Perceptually Lossless, and then you can go up to Render at the top and select Render Animation. And that's it for this tutorial. Thank you guys so much for watching, I really appreciate it. I hope this was helpful in learning how to use Grease Pencil when combined with 3D meshes. Also, if you'd like to learn more about it, you can check out my course I just released with CG Boost called Master Grease Pencil in Blender. In this course, I'll walk through everything you need to know to get started with Grease Pencil, and by the end, you'll have created this medieval fantasy village scene. There are also project files and exercises included. Right now, it's in early access, so it's 20% off, and you can find the course on the CG Boost website. There are additional parts coming soon, and these will all be included with the purchase price. You can find the link in the description. If you guys have any questions, feel free to leave a comment below. And if you do end up creating this microscope, tag us on social media. Thanks again, and see you guys next time.